Question 5. For the instant represented, car A has a speed of 100 km an hour, increasing at a rate of 8 km an hour each second, so that's both the speed and the acceleration downwards, whereas car B has a speed of 100 km an hour, but it's in a circular motion. But this time it's decelerating at a rate of 8 km an hour each second, so the acceleration of course is upwards because it's slowing down. So determine the acceleration that A has with respect to B. Now I'll do this both ways, and the first time didn't see properly the diagram x and y, so I've assumed that x and y are defined according to the coordinate system here, and I'll show you how to do it to match the question later. Okay, so looking at the problem, you get your acceleration downwards of A, your acceleration upwards for B, even though it's travelling downwards because it's slowing down. But because it's in a circular motion, you've also got this component AN towards the centre of the circle. So, first thing is to convert these into into meters per second squared. So you divide this by 3.6. 2.2 meters per second squared, and minus 2.2 meters per second squared for B, the tangential component of the acceleration of B, and the normal component of the acceleration of B is the speed VB, which is 100 divided by 3.6 divided by the radius, rho, 300, 2.57. So that's pretty much the calculation, all the calculation you need. The rest is just vector addition. So we write our vectors. It's important to write the acceleration vectors AA. Now according to this system, where J is positive up, then acceleration of car A is negative 2.22J, and car B is positive 2.22J minus 2.57I. So we've got our two vectors. If you want to get the acceleration of A with respect to V, then it's A minus B. If you want to get B with respect to A, then it's B minus A. So quite simply, just substituting the terms, A with respect to B, where the coordinate system is this one, you have plus 2.57I minus 4.44J. Now, in the question, it defines the coordinate system as follows. So I is positive going negative down and J is positive going to the left. If that's the case, then our vectors A, acceleration of A, is positive in the I direction, and our acceleration of car B is actually negative in the I direction. So if these are the two vectors we use, then the two relative vectors are recalculated here, and this is the one that matches the answer given at the beginning of the question.